Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome to chemistry class. I am Saliu Abdul Wahab, your chemistry teacher. We want to quickly look at the nuclear particles of an atom. Nuclear particles of an atom. The nuclear particles of an atom are the subatomic particles contained in the nucleus of an atom. Remember in our previous class, we said that an atom is divided into two parts. That is, the centrally placed nucleus and the orbitals that house the electron. Now, when we now talk about the nuclear particles, we are referring to the particles that are present in the nucleus, which means the particles that can be found inside the nucleus. And these particles are the protons and the neutrons, like as we have said. Protons and neutrons are referred to as nuclear particles. Just anytime anybody asks you to give the nuclear or list the nuclear particles, they are protons and neutrons, because these two makes the nucleus of an atom. Protons and neutrons makes the nuclear particles. They determine the atomic number and mass number of an atom. Of course, the atomic number of an atom is the number of protons present in the nucleus of that atom, while the mass number of an atom is the number of protons and neutrons present in the nucleus of an atom. Now let us quickly look at the atomic number. The atomic number is usually represented with capital letter Z. The atomic number of an element is the number of protons present in the nucleus of that atom. Now, when you are given an element, the number of protons that the nucleus of that element has is referred to as the number of protons. Therefore, without wasting time, the number of protons is equal to the number of electrons. The number of protons in an atom is also known as the nuclear charge. It is always a whole number and equals to the number of electron. Now, the number of electron, like as we have said, must be equal to the number of proton. But then look at their charges. The charge of an electron is negatively charged, while that of proton is positively charged. Then if the number of protons must be equal to the number of electrons of any atom, it means that an atom is electrically neutral. For instance, if the number of protons is 5, that means that it is plus 5 because proton is positively charged. If the number of electron is also 5, because the number of protons must be equal to the number of electrons. But remember that an electron is negatively charged, which makes it minus 5. Minus 5 plus 5 gives us 0. Therefore, for an atom to be electrically neutral, the number of protons must be equal to the number of neutrons. The only difference is that they are opposite in charges. Proton is positively charged, while electron is negatively charged. Therefore, an atom is said to be electrically neutral. Why? Because of their difference in charges. But number of proton, number of electron are exactly equal. Now let's look at the mass number. The mass number is represented by a capital letter A. The mass number of an element A is the sum of the number of protons and neutrons. Now, we know what is a proton. Now we know what is a neutron. Now we know where protons and neutrons are found, right inside the nucleus of an atom. Therefore, when we talk mass number, the mass number of an element is determined by the number of protons and the number of neutrons. Add the two of them together, it gives us the mass number. That is, number of protons plus number of neutrons is equal to mass number. The nuclear symbol of an element is written as capital letter X, and behind it we have a superscript A, capital letter, and a subscript Z. Of course, A represents the atomic mass of that element, while Z represents the atomic number of that element. But what is the element? The element is denoted as X, where X can be any of the 118 known elements. X can be hydrogen, helium, lithium, sodium, potassium, magnesium, aluminium, and so on and so forth. But then A is the mass number. And what is the mass number? Number of protons and number of neutrons summed together. While Z is the atomic number, and that is the number of protons alone. The number of protons alone. On this note, you can see that the nuclear symbol of sodium atom is denoted as Na. Remember, the chemical symbol of sodium is Na, and I told you that Na is derived from the Latin name. And what is the Latin name of sodium? Natrium. From natrium we have Na. The atomic mass of sodium is 23, while the atomic number is 11. Remember that the atomic number is also the number of protons. Therefore, to get the number of neutrons now is very easy. Let's take it. A is equal to 23 and Z is equal to 11. That is, atomic mass of sodium is equal to 23 and its atomic number Z is equal to 11. To get the difference between the mass number and the atomic number now, which is the neutrons. To get the number of neutrons now, just find the difference between the atomic mass and the atomic number. That is, atomic mass minus atomic number, which gives us the number of neutrons. Look at the board. You will discover that mass number, which is 23, minus atomic number, which is 11, gives us the number of neutrons. And the number of neutrons in sodium atom is 12. That is 23 minus 11. Therefore, mass number is equal to the sum of the protons and the neutrons, while the atomic number is the number of protons only. But also remember that the number of protons is equal to the number of electrons. Hence, when we talk nuclear particles, as a way of summary, nuclear particles are those particles contained in the nucleus of an atom. They are protons and neutrons. And of course, we have seen their charges, and then we said that the sum of the proton and the neutrons makes the atomic mass. While the proton alone, the number of protons alone, is the atomic number. Don't forget that an atom is electrically neutral. Why? Because the number of protons is equal to the number of electrons. See you in my next class. Do not hesitate to subscribe to our channel. Thank you very much.